You know, we've been working on the upstream efforts, and it's been going pretty well. So I just wanted to do a report of the milestones that we've been reaching. So of course, a summary of the program. So this is a heavily demanded project. Last year, there was a statistic, 89% of the community wanted this to be done. The nice thing about this project is heavily supported by community members. Amazon is involved. Eon with Arshad, he's done an excellent job on the documentation stuff and helped with reviews and things. Of course, ORNL for myself, and HPE has also been involved, especially with Sean's work. And the Luster Collective is very supportive of this work. There's two trees that is where this work is being, I do this work. One is my private tree for the native client, and the other one is, of course, the work is done on the OpenSFS branch. So, and I do plan to create a Luster branch and plan to eventually try to get it to migrate to vJur. So for people who don't know, vJur is the main development server for the Linux community. So what is needed for upstreaming? So I need a key of Web of Trust. So all Linux maintainers have to have a key of trust. I have to actually see someone in person, or they have to see my face and validate that I am that person with ID. Yes, it's a complex process, and then you give them a special key so they can do this. And of course, we need to validate the native client work, and we do that by porting that over to the OpenSFS branch, and we've been heavily doing that. Most of that work is actually done, so anything that we find that was broken in the native client, we can backport it easily. And the biggest thing that you're going to see is we are working to build the upstream client code in the OpenSFS tree. So actually, it's a bidirectional process right now. So right now, we can actually take the OpenSFS tree kernel code and put it in a latest native kernel and actually build it and test it out. And vice versa, we want to be able to someday bring down the native client and put it in the OpenSFS tree and build it. It would be the source of truth, as you could say, for that tree. So what are some things that are missing in this native client work is the GSS code. So that was ripped out. I'm working on restoring that and making that work. And of course, updating to the latest kernels. We have to do some FS script work. And Folio is required, which Sean is going to give a great talk on about that. And as I was saying, Linus likes to pull from the vJur servers, the source codes. So what does the kernel state look like? So one of the biggest things you're going to notice is we support the latest kernels. At this time, it was 6.19 and a 7.0 kernel work was being done. It's going to be landed shortly. Same with all the pre-5.0 kernel stuff is being removed. It's on the verge. The patches are in review. So that's all the RHEL 7 stuff. There's no more RHEL 7 stuff. It's all gone. The other ththing is the InfiniBand driver uses GDS, which is not supported upstream. Tim Day is working on peer-to-peer DMA. So that is also in the works. The nice thing about this functionality is this will work with more than just NVIDIA drivers. We can use various types of hardware, GPU hardware. So that is going to be very, very good. And as I was saying, the Philo work has been progressing very, very well. So that's in development. Right now we support small Philos, and large Philos will be supported. That's a good performance boost on these newer kernels. Now that RHEL 7 is gone, we can look at decache issues. So you can actually crash your node with directory renames. And the reason for that is to explain it, in the decache, you can have aliases, and it's usually for files. We use aliases for our special FID directory, but actually the Linux kernel sees directories, if they have more than one alias, is actually a rename. So it gets confused and it doesn't know what to do. So that can actually break things very badly. Native SF script support needs to be done, and I will talk to Sean about that on Developers Day. And the other thing, if you look on the client side, so one of the things is Lustre had its own hash implementation, and the kernel uses our hash tables. There's only one thing left on the client side, and that patch is in the works. We're trying to get it to pass, OLEG setup. So the fun thing is when we move to our hash tables, all these race conditions that we never saw before show up. And I've been squashing them over and over and over and over again. Each one is a new layer. It's like peeling an onion. The other thing is if you look at your proc directories on your client, you're going to only see two things left. It's almost all gone. So mdstats and pool proc files. And those will be moved over to debugfs and also for the netlink API. So one of the things that we've seen is there's something called secure boot Linux. So secure boot Linux actually disables debugfs. So all our complex structures are gone. So we've been, as Andreas brought up, we are working on netlink to replace all those things. So, and the netlink API actually works with the libyaml library, and we can actually put like pyaml on top. So there's plans to do wrappers so that you will be able to do like Python and import the things to use Lustre with pyaml, and it'll make it easier to port your work. So instead of just opening a file, you'll have to do a little bit of work, a little bit of changes for your applications. And lastly, now that I'm almost finished with all the kernel cleanups and everything, IP version 6, I'm actually going to be looking back at this and trying to figure out resolving problems. So one of the things is IB, the InfiniBand driver needs IP version 6 support. LNet self-test, which I'm starting to submit patches for, that doesn't support IB version 6. And there's a lot of internal changes for that. UDSCP support also. And then, of course, Andreas brought this up about the Lustre UID to NID mappings. So that needs to be resolved. And GSS has been neglected for IP version 6, though if we use SS keys, that makes it a little easier. And there are a couple other regressions that show up, like NID ranges. Some people want NID ranges for everything, so we have to do that, but also support net mask. So those are the things we're going to finish up, and that's what I'm going to be focusing on the next several months. So, all right, so now the other thing that you're going to notice when you download your source code, you're going to look at your tree, and you're going to like scratch your eyes and say, what happened to my tree? Because it's going to be very different than what you've seen. All those automake files, they're going away. So the reason for this is because if we're going to download the Linux kernel tree and try to build those modules, those are just make files. The only reason we had make files is because those are from the days when we supported Solaris and Mac OS and all this other stuff. So we don't need those. So that is, so that's going to be a big difference. All you're going to see is make files. That's almost done that work. The other one is we've been separating the kernel tree and non-kernel items. So if you look in Lustre, there was like documentation and utilities and tools, and then the kernel modules. It's quite a mess. So we're kind of moving this stuff out and putting the kernels, because when we download the tree, we're not going to have those items. So also, the other thing you're going to see is that we created a Lustre compact area. So what we've done is we've tried to make the header file. So for a long time, we had like Linux-miscellaneous and Linux-fs, all these strange libcfs headers. So we've now actually made them to mirror the tree so that when we go through and we download the tree and we want to build this backwards module code to support older kernels, you just take the headers and expand it to Lustre compact, the directory, and it'll actually build. So it's very minimal changes to support this. And if you look in this Lustre compact directory, you'll see lots of .c files that mirror the Linux kernel tree. So that's all the compatible code for older ones. We're also broke up a lot of the libcfs and compat stuff. So libcfs had not only the debugging infrastructure, but it had all this old kernel code support stuff. So that has been pushed out. It still compiles as one module, And there's much discussion about like how to handle that. We haven't figured that out, like how to do this. Because we're like, should we put that as a separate module? But then some people are like, no, it should be built into libcfs, even if we do the native client. There's a lot. We'll have to have that discussion on Developers Day. And then lastly, one of the other things, I don't know if it'll be done for 2.18, is we've talked about reducing the number of module counts. So it would be down to just a handful of modules, LNet, like libcfs, and then just Lustre. That's what you would see. And then there would be a Lustre server module, and that would be it. So with all this work, actually, we had this discussion. I had this discussion with Brian earlier. We were talking about the separation of how mounting works. So right now, when you mount Lustre, you do a -t Lustre. So in the future, you're going to have to do servers with mount -t Lustre _t. It's a different code path. We want to separate the client from the server. So right now, when you mount a server, it actually goes through the client code and loads it loads a bunch of client code just to mount, and that's not necessary. Brian actually discussed the idea that do we even need to mount, actually, on the server side? So that's something to think about. The other big change is we're moving to the FS Context API. This was a requirement for the newest kernels. This is an incredible change. It's a big change that will help with how you manage things. So originally, for mounting, you had to pass all these mount strings and for the options and structure it. With FS Context, you can do the parameters separate from the mounting. So what that means is that like all your OSD plugins can go away. There's one universal API. We can manage the structures. We don't have to do ZFS handling separate special to do mount options. We can actually just use a universal API. Another thing that was a nice project that's coming out of this is K-Test. So Tim Day developed something like K-Test. I've played with it. It still needs some love. This is how we validate the open SFS tree against the latest kernels. It's this nice build infrastructure. We're trying to make a new way to create testing where you can test your Lustre like we do with Malu, but in a much easier and simpler way. And of course, we have new debug work. So one of the things is we have a lot of custom APIs. So Upstream, they've created a new memory leak framework. So there's this new proc file. And it's very handy. It actually tells you exactly where the memory is being allocated, what type of class. It's much more robust than what we have. And there's a ticket open to like look at implementing and using that. The other thing is we're looking to embed for eBPF. We're going to be able to do trace points. We actually wanted this for the lab, so we do some of this tracing. And then we also are looking at doing this tracing with LNet. So there's actually a ticket open and some early work where we use eBPF. Because right now you can't really debug LNet because if you turn on debugging, it overwhelms it. So the goal is to actually use this process. And of course, as we discussed, there's the LNet netlink API stuff. So you can use that instead of opening a file and debug FS. And we're going to have all these wrappers. And one of the ways where I'm going to show a good example is we have two applications utilities, LL job stats and LL OBD stats. We could easily port those. One of them is definitely a Python script. So just a couple lines change with the proper Python import for the netlink to the C code, and it would work. So we're going to do that. And of course, I want to give special thanks to everyone who's doing this work. So Neil Brown, he's not as active as before, but he's going to help. I'm reaching out to him to help get into the Linux community to get it ready to push this stuff upstream. Arshad for doing all the documentation work and reviewing the patches. And Sean, of course, for his Philo and newest kernel support. And Timothy Day for really participating in these efforts. And of course, the WAM Cloud team. And now the Lustre Collective. I forgot to add them since they're newer. So the conclusion, so the work is progressing, and we're hitting these incredible milestones which we're going to complete. I think actually by 218, I think client size, we can have the tree ready for all this stuff. We have these new features and improvements from this work, which will benefit sites. And we have healthy momentum. Usually 4 or 5 patches are landing related to this work every landing cycle. And of course, I have to give this spiel. Thanks to the U.S. Department of Energy for sponsoring all this work. They've been very kind to allow me to do what I love doing. Thank you. Oops. Any questions?
You still have a little more time if there's something you wanted to elaborate on.
That's what I was wondering. I kind of did a brief overview. If you have any questions about specific things about how it'll impact you.
Hey, James, thanks for all the effort on this. It's a huge effort, and you've been talking about it for a long time, and you've been banging on it for a long time, and you made great progress. Thanks for updating us. But is the goal still in sight? I mean,
yes.
What I'm trying to ask is are the Linux maintainers and the Linux community going to accept?
Yes. That barrier is passed.
Right. Okay. Yeah. And they're still on board.
They're still on board. Yeah.
So you do this work, you get to the finish line, and you'll realize success?
Yes.
Well, that's great. All right. Thanks.
So I'm Tim Day. I'm one of the people that James mentioned also works on Upstream project quite a bit. Our tentative goal is to have something on the list before the next LUG and perhaps before the next Linux storage and file system conference. It's not a guarantee that all the maintainers would happily accept it the first go around, but when we went to LSF, James and I, there was a pretty positive reception. So I think optimistic that we will eventually get it in, but hoping to have at least the first go around posting patches on the list within like a year or so.
In fact, on the FS Devel list recently, there was a huge discussion about what are the barriers to accept into the mainstream kernel for file systems, because 2 file systems show up from time to time, and they just had 2 more file systems that wanted to go in, and they were like, well, what do we need to really, we're having these constantly thrown over the fence at us.
You mentioned that it had been proposed to get rid of the concept of mounting the server targets. I was wondering if you could elaborate on what an alternative might be for that.
Not mounting, actually, at all. that would be the alternative. I mean, like, you don't have to use that process. It's something that actually just was thrown at me, and I have to think about it.
It's a bit of a weird thing to do. It always struck me as funny that that's how we start a server process.
Yes, that's what was pointed out to me. I never thought about it. I think it's it's from the old days of like when we supported multiple OSs and stuff like that. Also, I was thinking a little bit about it, like after it was discussed. I think there's the idea we kind of use the VFS internals, like D entries and inodes, and so we use the mounting as like a way to build that structure.
Gotcha.
So I was trying to think, how can we build it without that? I don't know.
Okay, thank you.
At this point.
If I can just jump in here a bit. I mean, we do use the mount points for LDiskFS at least, maybe not so much for ZFS, but we need the mount points for like running FS trim and resize and a number of things to have ioctals to go through, right? And DF is not terrible either. To know what file systems are mounted, because otherwise you wouldn't see that those devices are in use, right? And so lots of tools, they'd say, oh, look at those empty disks, let me reformat them, or whatever, right? So we have protections against that, but having the mount points is good for other reasons as well. But it is, some people do think it's kind of strange, right? But NFS and things, the NFS server does mount the file system. It's just that we don't let the users to modify the OSTs and MDTs because they don't represent a sensible namespace, like NFS is just a direct export, so.
Is there anything you feel that the Linux community is looking forward to from these upstream efforts, aside from just having Lustre in the tree? I know there was some talk probably several years ago about the tracing system in Lustre compared to Linux's tracing system at that time, but I don't know if there's anything else you can think of.
So I could think of two things that they're going to digest and rip out. Number one is the parity erasure coding stuff we have. So some of it, they're going to want to pull that out and have everybody use that code. That will be interesting when we have that. The second thing was one of the things that when we were in staging that they pulled out but it never got pushed was the range lock.
Oh.
That was another thing that was of interest to several file systems. Oh yes, that was the other thing, the parallel mount directory operations too.
Let's thank our speaker, James.